Hello and welcome to the sixth lecture of Introduction to Logic. Today we will be taking some exercises with the help of truth tables. Now, as you know, as we have discussed in the classes as well as in the lectures before, that truth tables can be used for both checking the validity of an argument as well as checking the truth or falsity of a statement. So we can also find whether a statement is a tautology or a statement is a contradiction or a statement is a contingent statement or proposition. So today we will take a few questions, few basic types of questions, and I'm dividing this lecture into three parts because there has also been a suggestion which has come from students that we should keep the classes a little bit shorter. That means classes which are 40 or the lectures which are 40 minutes duration are a little bit boring. So what I will do is that I will keep the lecture shorter and more so that you can at your own wish or convenience can check whichever lecture you will like to see or watch. So what I'm doing today is that I'm dividing these lectures, because if I would have taken a single lecture of this, so it may have gone for more than an hour or so. So I'm dividing into three parts, three smaller parts, maybe of 25 to 30 minutes duration or even less sometimes. And we will take few basic types of questions. So now, as if you will see your book or if you see a lot of materials on internet, there can be different types of questions which can be asked for truth tables, and I'm refraining from taking an example which is having a lot of values, because then the truth table will be bigger in size. Like say if we have five simple propositions, so the truth table will be of 32 rows, right? And if we have 6, so it will be of 64. So you will see that it will be difficult to draw it here. So I will keep it shorter and take 2, 3 or 4 propositions kind of thing. But we can do for more as well in our copies, or if you have any doubts, so we can always solve. So there are types of questions, like in your book also you will find questions like that. Like suppose if a question says that the value of A is true, fine. So this is an A proposition which is true by nature, and the value of B proposition is false. So what will be the value of, say, this one? Negation of negation A dot negation B dot negation A dot negation A. So this is the question. This is the first question which we are taking for today's class. Now, how to solve this question? Either we could have made the whole of the truth table, like if we make the whole of the truth table of A and B and then find. But it is already given that what will be the value of what will be the value of A and what will be the value of B. So we need not draw the whole truth table. How to draw the whole truth table and so on is something which we have already taken, right? Or we have already discussed in previous lectures. We will take a few today as well. Right now the value has been provided to us. So how to solve this question? Now the first thing which you need to understand is that how you are going to put certain brackets and so on. Like suppose if you need to see that the left hand side brackets and the right hand brackets are equal by nature, right? So if I put this as here and here, and I make this as this and this as this. So now the bracketing is proper or as per our convention. Now you can see that there are 3 brackets in the left, 1, 2, 3, and 3 brackets in the right, and you know that this is the first bracket, this is the second, and this is the third bracket, as we have discussed in the previous lectures. Now the bracketing is done. So because there can be some anomaly with the bracketing, so first you have to make it proper. If there is no bracket, so how to put the brackets and so on, you know. Now we need to find the value of this. Now what will be the value of this? The value of this is here, because you know that this is the main connective, right? So this needs to be calculated, and this is something which you should understand, that I need the value of this. Like suppose if say somebody in the question says that if A is true, B is false, what will be the value of this? You found the value of this, it is going to be the wrong answer. If you found the value of this, or I do not know this, all these things will be false answers. The right answer will be this one. So you need to understand this. Now it is going to be simpler if you could have drawn the whole of the truth table. But right now we are not going to draw the whole of the truth table, rather than make it shorter and get the answer. Now what is the trick for it? If you do not understand it properly, so you can make the whole of the truth table and then draw and this and that. But you do not need to draw that, and you will follow it very fast. The first bracket which you need to solve is this. Fine. So you put the values of this. This is A is true, B is false. So the negation A value will be false, dot the negation of B value will be true. So false dot true is false. So I will directly write it as false. So this has been taken care of. Fine. So this was the first step. Now with what I need to find this value? With this, because this negation is on this bracket, right? So I need to put the value here. So the negation of false will be true. So I remove this as well. So now it has become true. Now I need to find this and the value of this, right? So what is the value of A? True, true. So it is false. True dot false is going to be false. So I am writing this false here, and I am removing these two. Right? Okay. So now I have the answer of this up to this value, means up to this value is false for me. Fine. So I have checked up to this value, because we found the value of this, then we found the value of this, and then we found the value of this, and it came out to be false. Now what is the value which need to calculate it? Like this. So f dot negation of A is also false. So false dot false will be false. So we have calculated that this is false. Now the negation of this. So the negation of this, and this is true. So we remove this. So what is the answer? The answer is that the value of negation of negation A dot negation B dot negation of A dot negation of A is a tautology, right? Because this whole has come out to be a tautology given A is true and B is false. This proposition, if A is not true and B is not false, it can take both the values. So you can draw the whole of the truth table and you can find the value of this, right? But right now it was given that A is true and B is false. So what is going to be the value? If I have calculated it incorrect, or if you feel like that there is another way, so you can always put it in the comment. Okay, let us go to the next question, because we will try to solve different types of questions in this class. So this is one type of question where you will be given some kind of values, like what is the value of A, what is the value of P, what is the value of Q, what is the value of R, something like that. And then you will be given an expression and you have to find the value. So in those cases, you can use it just by putting the values, and you need to understand the bracketing, and you need to understand that which is going to be the main connective, so the last value of it. So that is the whole idea of doing a question like that. Now suppose if you are given a question like P implies P, where you do not know the value. There can be a question like, I do not know the value of P or Q. The value of P or Q is not given. So what is going to be the value of P implies Q? So one way of solving it is that you draw the whole of the truth table, right? So you draw the whole of the truth table. You know how to draw the truth table. This is going to be true. This is going to be false. This is also true. This is false. This is true. This is false. So first you will calculate the value of this. True is true, and false is also true, right? Now you need to calculate the value of this. True, false, true. So you find this to be a value. So this is a tautology. If they would have said that the value of p is false, if the value of p is false, so how to calculate it? It's simple. If they say that what is the value of this if p is false, so you can put false, you can put false, you can put false, false is true, and false implies true is true. So it will also come as a tautology. It is also a true proposition, right? If the value of p is true, what is going to be the value? Again, it is going to be true. So all these things, these kind of questions can also come. Now let us come to the third type of question. What will be the third type of question which can come, right? That how you need to solve a value of something which has been given. Now what they said is that you do not know the value of this expression p dot p dot, what is the expression which is given? P dot negation p. Yeah, p dot negation p. You are not given the value of p. You do not know whether p is true or whether p is false. So what will be the value of this one? Okay, so we draw the whole of the truth table. One way is definitely to draw the whole of the truth table, and you will find the value. This is something which we know. So we suppose if we draw true, false, here also true, false, here also true, false, and this is the negation of it. So I will directly make it false and true. So this is going to be false and this is going to be true. If you see, I wrote the value of it here and I put the value of this here. So it says that this is negation of p and this is the value of p. You can use these kind of expressions as well. Now if you see the dot result of this, so this is going to be false and this is also going to be false. So this is the result. Now what is the value of p dot negation p? Now this is the question, right? So if you true false and false false, so you will find that true false is false and true false is also false. So you know that this is a contradiction. P dot negation p. So this is going to be a contradiction and something which you can very clearly verify. Now suppose and you can always say that if this expression comes, you can always say that the answer of this is that it is a contradiction, right? Fine. So not a problem. Now suppose if I change the value and make it p wedge, p dot negation p. So the things will remain the same. We will have this only which we need to calculate. Now this is true wedge false is true, false wedge false is false. So what will be the answer? The answer of this is that it is a contingent proposition, right? Because there is one true and one false. Another way of saying it is that the value of p wedge p dot negation p is p, right? Why? Because p can take both the values true or false. So this will have no impact. What will be the impact now, or what will be the answer to this question? This whole question is nothing but p. In fact, later on we can also solve that p wedge p dot negation p is nothing but p. You will find that we will find the value of all these things as just p, right? Now why I am saying that this is going to be important, or why this question was important for us, and why you need to understand that how you are going to solve these kind of questions. Like suppose, hypothetically speaking, I will take few more questions in the examples in a later phase, but right now just to give you an example, suppose there is a question which gave you some values or has not given you some values. Like they can say that the value of p and q is unknown. So they can say like this, that p and q value is unknown, a and b's value is true, and x and y value is false. And then they gave you a very big expression, right? some very big expression, P dot Q A wedge B X implies Y, and then there is another material implication, or there is an equivalence in something, and you have given a very big value, right? And you are calculating it. Now, there can be, and this is what you need to understand, that there can be an expression like the last one. Like if you get a value like P wedge P dot negation P. So you know, irrespective of the fact, whatever the value of P or Q is, because P or Q is unknown, right? Whatever the value is, it will always come out to be P, or a contingent proposition. Or suppose if there is something like this value, so it will be a contradiction. Irrespective of what is the value of P or what is the value of Q, if A wedge A and B, suppose there is something like A dot negation A has come, or A, or say B wedge negation B has come. So this is always going to be a tautology, irrespective of the fact that the value of B is true. Or suppose if it would have been X or Y. So you need to understand that this expression is a tautology. This expression is a contradiction. And an expression like this is going to be a contingent proposition. Once you understand these small things, and therefore why we say that logic is very structural by nature, that irrespective of the value of A or say B or say X wedge X, suppose it has come, irrespective of the value, this is a tautology. Irrespective of the fact that whether the value of X is false or X would have been true, whatever. So you need to understand these small things, and you need to figure it out what is going to be a tautology. A basic expression of tautology is X wedge negation of X, or A implies A. Whatever way, this and these are equivalent expressions. These are tautologies. Fine. And if there is an expression like X dot negation of X, then this is always going to be a contradiction. So these basic things are certain things which you need to pick up slowly and slowly. We will give you the list of all these things, and you will work out more even out of it. That is not going to be a problem. But if you see the heart and soul of logic, or as I say, the signature of logic is nothing but the structure. Once you understand the structure properly, you will put values in a fashion that will always give us very meaningful results, that will give us true results, and so on. So once you understand these structures, you need to figure it out faster. Like if I remind you, all of you have studied trigonometry. All of you have studied it, say, from 9th to 12th standard. I do not know how these days in schools trigonometry is introduced. In our days, it used to be from 9th till 12th. So all of us used to study trigonometry. Now what happens in trigonometry, and something which you will understand, that this is an akin and analogous understanding to logic. First, trigonometry is introduced, very basic rules are introduced, those are told to us, and we start solving them. Then slowly, the previous exercise questions becomes an identity for us, because we know that if this things will come, so it will become cosec theta, or this will become tan theta, because we have already solved it, and we know that after 3 or 4 steps this becomes a tan theta, or this becomes a cosec theta, or whatever. Logic also is like that. Once you start analyzing and you understand the structures properly, what will happen? You will understand that these structures will give this result, or that structure gives this result. So this is going to be helpful for you, because the more informations you will have, the more you will be able to use them, and use them with ease. So you try to figure it out. What is the structure of a tautology? What is the structure of a contradiction? Or what is going to be the structure of a contingent proposition? And once you understand them, and once you have these things in your mind very clearly, so it will be easier for you. Not only truth tables, I'm not talking about truth tables right now. Truth tables is a very small part of our syllabus. You will be doing a lot of proofs, and proofs will be the major part of your syllabus. So the more you will remember these datas, the more you will remember these informations, these small informations which will come and which will give you enough of impetus to calculate these things. So more you will be comfortable with this, that okay, this data is going to be transformed as this, that data is going to be transformed as this, and for these we will put those values. So this was all from my side for this lecture. In the coming two lectures also, we will be discussing truth tables and its usages in other ways, or say different kind of questions which can be asked by the say examination point of view, or from the books point of view, or you will also find it on internet, a lot of things which can be solved using the truth tables. So the next two lectures will be also devoted to truth tables, and we will check them in the next two classes. Thank you very much.